Hello, everyone. My name is Peter Cartmel. I'm the platform manager for the Galvanic Applied Science Sulfur-Chrome Gas Chromatograph. Today, I will be presenting an introduction to sulfur-chrome. We'll cover chemiluminescence, measurement, analyzer design, installation, and maintenance. Sulfur-chrome is a process gas analyzer, a gas chromatographic GC with a chemiluminescence detector. This is a third generation GC platform, best price to performance ratio available, over 25 years of installations. Designed for measurement certainty, process control, environmental compliance. Some of the features, advantages, and benefits are as follows. Simple calibration method, single cal gas for natural gas sulfur, reduced utility costs, electrical heated source, no flame out, advanced capillary columns, complex sulfur separation, detects extensive sulfur species. Photomultiplier tube, no hazardous detector, operator safety. Equimolar response, same accuracy ppb to ppm. Performance despite hydrocarbon change. Multi-stream capability, one analyzer can handle up to 8 streams. Pre and post odorized samples, rapid analysis cycle, every sulfur in 7 minutes. For the natural gas pipeline, it's mostly odorization stations. The sulfur species of interest would be isopropylmercaptan, tetrabutylmercaptan, normal propylmercaptan, and secondary butylmercaptan. For the NGL pipeline, LPG odorization station, the same for the sulfur species. For the natural gas liquid processing, sweetening, less than 100 ppm mercaptan, H2S, total sulfur. In the refinery, you have mercaptan oxidation, catalyst protection, and for that you would measure total mercaptans, H2S. CO2 plants, catalyst protection, again, H2S, total sulfur. So the chemiluminescence chromatography, it uses an injection system, a 10-port diaphragm valve, helium-activated sample injection, column back flush. On the right is just a typical 10-port valve that we use, and you can see the flow pattern on the valve. So basically, you got a sample come in, sample vent, carrier comes in on port 4, picks up the sample, takes it to the column, to the detector, and then once you get the sulfurs or interest out, you simply just backflush the rest of the sulfurs out as other sulfur. The capillary column, it's Teflon packed or steel coated glass, 30-meter wall coated, thin liquid layer on the inner tube diameter. It's used for complex separation up to C4 mercaptans or sulfide. We use a flameless reaction furnace, ceramic embedded resistor coil, thermocouple feedback for temperature control, and ceramic tube for SO formation. So this is basically what we call our oxidation reduction oven. So basically, after the sulfurs are separated in the column in the previous slides, we basically come down and we add combustion air to the sulfur, separated sulfur, and then into the ceramic tubes where we add hydrogen to do the reduction to SO. Part of the chemiluminescence reaction cell, this reaction cell is sealed to eliminate ambient light interference. Sulfur monoxide forms in the furnace and is mixed with ozone. So basically what you're looking at is SO after it comes out of the oxidation reduction oven. SO enters into the photomultiplier or the sample cell there. We add ozone to produce SO2, which then creates a light source. And the light source is picked up by the photomultiplier tube, giving us a signal proportional to the concentration of the sulfur. Part of the chemiluminescence reaction, this requires ozone. So we have our own ozone generator. We take oxygen, convert it to ozone, and send it to the reaction cell. Basically, what we do is we have our air drawn through the enclosed tube with electrodes down the center. We apply 7,500 volts to that electrode, and the electrode then produces ozone. The diaphragm vacuum pump preserves the sulfur monoxide intermediate. So once we get to the photomultiplier tube where the chemiluminescence happens, this all happens at a vacuum. The photomultiplier tube is extremely sensitive light detector. The output current proportional to the light intensity. We use the thermoelectric coolers to reduce the baseline noise. Keeping the PMT at a lower temperature reduces baseline noise. To the right, you can actually see the PMT. The unit itself is mounted on the wall there on the right, and that's where the chemiluminescence happens in that upper chamber of the reaction cell. The measurement. So basically, the reaction furnace, we operate at 750 degrees C. Sulfur reacts with air and hydrogen under vacuum. Sulfur monoxide is formed and sent to the reaction cell. Chemiluminescence chamber, sulfur monoxide reacts with the ozone. Sulfur dioxide and light is formed. The photomultiplier tube, light is detected at 350 nanometers and voltage generated, proportion to the concentration of the sulfur compound. And it falls under the ASTM method. So basically you have your sample, your hydrogen, and your air in the oxidation reduction or the reaction furnace. Ozone zone is generated, and it all comes together in the sulfur chemiluminescence detector, and it produces UV light. And this is all done under vacuum with the vacuum pump. Measurement. So the typical retention times, H2S comes out at 80 seconds, COS or carbonyl sulfide at 86 seconds, methylmercaptan at about 120, ethyl mercaptan at 180 seconds, and dimethyl sulfide for approximately 200 seconds. So you can see the chromatogram as the sulfurs are separated through the GC section of the oven. The individual peaks will come out in this typical order. So you would see the H2S. What's not shown there would be the COS right after the H2S, and then you would see all your mercaptans and your dimethyl sulfide and so on out. So these are typically some of the odorants that are added to the natural gas to give you that rotten egg smell if there happens to be a leak somewhere. So measurement again, the parameters. These are some of the sulfurs that we measure, and eventually, once we get our tetrahydrothiophene out, we backflush and we can get your other sulfurs to give you total sulfur. We can measure ppb to ppm level, equimolar response. What the equimolar means is because when we reduce all the sulfurs to SO, you're only actually dealing with one sulfur compound. We only require one standard H2S standard or sulfur standard in a calibration. T90 for the 15 minutes applications specific, sulfur specific, no known interference, not affected by hydrocarbon changes, upset or blending. Sample requirement. Gas or vaporized liquid, Silco steel sample lines. The utilities require helium gas, basically 20 cc's a minute. Helium we'd like to have set to 80 psi. Hydrogen flows roughly around 80 cc's a minute. We require 60 psi per utility. The furnace ozone generator air is done just from ambient. The PMT purge instrument air is roughly around 30 cc's a minute. And the reason for that is we tried to, because the PMT is being cooled, we just try to keep any kind of frost or liquid building up on the PMT and causing issues with the analyzer. The utility purge air is 80 standard cubic feet per hour. That's to maintain the Div 2 rating. Calibration gas, H2S and nitrogen, 15 psi. Enclosure, we have a painted steel. It's basically a 28 by 40 by 16 cabinet. Weighs 125 pounds. 0 to 50 degrees C ambient operating temperature. For electrical utilities, 100 to 240 volts AC, 600 watts. The certification is a Class 1 DIV2 purge system. The sulfur chrome design. For communications, we have 4 analog outputs, 3 analog inputs. It has Modbus, has Ethernet capability, digital inputs, and relays. Corrosion protection, sealed from the Pyron epoxy components. Analyzer operation has a local display and has a keypad control, which is intrinsically safe, so it allows the operator to make changes, schedule maintenance quarterly, change the air desiccator twice a year, replace the pump diaphragms. The desiccators are located on the right-hand side of the analyzer. This is where the ozone air is drawn through and the combustion air. So we're delivering dry ambient air to those components to prevent any damage to the analyzer. Installation examples. So you can see the couple of different areas or different designs with sample conditioning on the right-hand side. It's in a different enclosure, whereas on the left side, it's just a standalone sample comes in directly to the analyzer. Generally recommend 2 vacuum pumps, and you can see there's 2 vacuum pumps in both applications. Typically what we do there is one vacuum pump is in standby mode while the other one's operating. And when it comes to your quarterly or 6 months operation to replace the diaphragm, you simply just turn the other vacuum pump on and take the other one out of service so you can do the maintenance. And this prevents you from having to do a maintenance shutdown on the analyzer to do the repair to the pump. Service is we have local on-site for startup, PM and training, and then also from the factory we do FATs, remote troubleshooting, and basically phone support. So why sulfur chrome? Multi-stream, the advantage, one analyzer can monitor up to 8 streams. For the sulfur chrome, under calibration, one standard for all sulfur species. Sulfur separation, column handles complexity. What if scenarios? Upset, hydrocarbon change, accuracy is not affected. Process blending, accuracy is not affected. Varying concentration, equimolar response to all sulfurs. Why sulfur chrome GC again? Not one size fit all. Some of the technology that we use to measure H2S is the Acculase, which is a TDL range is 0 to 10 or 0 to 500 ppm. No interference. Sensitivity is 0.15 ppm. T90 response, 30 seconds. Again, interference, none. Consumable, none. Operation simple. And multiple parameters is also, we can measure CO2 and H2O in the same analyzer. ProTech, which is a tape analyzer, the ProTech Nano 3, its range is 0 to 300 ppm without dilution or 0 to 10% with dilution. Sensitivity on the tape analyzer is basically 0.005 ppm or 5 parts per billion. T90 response is 3 to 5 minutes. Interferences, there is no interference on the tape. Consumable, yes, we have to replace tapes on a monthly basis. Operation is simple. Multiple random parameters. It can do H2S or total sulfur, or H2S and total sulfur the same. The FPA 4100, it's a direct UV. Its range is 0 to 0.5 G per L, 0 to 100% range for H2S. Sensitivity on this analyzer is 5 ppm. T90 response is 30 seconds. It does have interferences. Consumable, there's none. Operation is simple. Multi-parameter, no. The Accuchrome, it's a TCD GC based analyzer. Its range is 0 to 1,000 ppm or 0 to 100%. T9 response time is 4 minutes. Interference, there's none. Consumable, none. Operation complex, multi-parameter, BTU, and hydrocarbons. The upgrade benefits: number of samples, single stream to a multi-stream, communication for the 20 or for the 20 with Modbus. Electronics in the legacy is old. Sulfur is updated. The weight, the oldest analyzer weighed about 250 pounds. The new one, 125 pounds. Measurement certainty, rapid return on investment, identify organization issue, product quality and compliance, automated custody transfer, validation, avoid pipeline walkout. Any questions? You can contact in the Galvanic sales on platform managers, myself, Peter Cartmel, and we have local authorized distributors.